In this video, I want to introduce Python, which will help us to solve mathematical problems. If you're totally new to Python, please watch the videos in my playlist Python for Data Science first. We start with a very simple problem, the factorization of quadratic equations. Let's look at an example. X squared plus x minus 2 is equal to 0. There are obviously two solutions, x1 is equal to 1 and x2 is equal to minus 2. Hence we can factorize as follows. X minus 1 times x plus 2. How can we teach Python to factorize quadratic equations? Let's do some pseudocoding first, which means we don't write down actual code, we just focus on the logic. First, we need to input our equation of the form ax to the power of 2 plus bx plus c is equal to 0. The user should be asked to specify the parameters a, b, and c. Then we have to check whether real solutions exist. You should know from your school days that the solution of a quadratic equation can be written as minus b plus minus the square root of b to the power of 2 minus 4ac divided by 2a. The value in the square root, the so-called discriminant, cannot be negative. Of course, we will cover complex numbers later in the course, so we will be able to express solutions in this case. Once we know that real solutions exist, we need to apply the solution, the one we see here, and do the factorization. We should also handle the special case where the discriminant is equal to 0. Then we should receive the factorization as an output. Let's try to implement that in Python. It might be useful to start with a print statement. Say ax to the power of 2 plus bx plus c equal to 0. Please provide the parameters a, b, c. Then we ask for input using the input function. Note that all inputs will be regarded as a string by Python. So for instance, I can ask to specify the parameter a. I'm just running the script and I can input a value. And you can see that this value now appears in my variable explorer. Note that the type is a string. So if I want to work with a as a numeric, we have to convert the string into an integer using the int function. Let's reassign a and run it one more time. And now you can see we have an integer. The problem with this code is obviously that if I don't provide the correct input, it will create some errors. I'll give you an example. So if I input here a float, so say 7.8, it will raise a value error. Now this can be handled in multiple ways. I show you a try and except statement. So here we have a try statement which encourages us to use the integer function if a is indeed an integer. If that doesn't work, it will print an error message. So let me just run this. So if you input an integer, it will work fine. If we run it again and we now input, for instance, a string, it will ask us to input an integer. And as you can see, the code runs through and nothing further happens. Ideally, if I don't input the correct integer, I want my code to go back to the question. So how can I do this? There are again various ways to implement that. One way is to use a while loop. So I use a while loop and I specify here, for instance, missing for missing input. Before entering this loop, I set missing equal to true, so the loop is running. All of that is moved inside the loop. If I can convert correctly, I set missing equal to false. So that will stop the loop. So now I'm inside the while loop, which keeps running until missing is false, which only happens if I can convert the input into an integer. Let me just run this. So if I now put in some nonsense, I go back to the question, I put in further nonsense, it goes back, I put in an integer, and it stops. So that's a nice way of implementing that. Now, it might be useful to put all this code here into a function to reuse it for the other parameters, and then loop over the 3 parameters a, b, c. Good, so here I specified a function which I call input underscore parameter. I put in the argument, for instance, a, because I want to switch it to b, c, and so on. I specify that the argument is a string, but this is ignored in the case of Python, but it's kind of nice for someone else to read my function to know that I intend a to be a string. Then I specify a list of parameters. Note that all the entries are strings. And I start an empty list of values. It's just an empty list, and I append this empty list with the parameter values, where inside the for loop I call the input parameter function, and I pass in par, which runs through the list of parameters. So I made one modification just to make sure that we don't confuse the argument and the value of the parameter. I just put here num for number and try to convert this. And of course my return should also have num for number. Let me just run this and see what happens. I put in a correct number, I put in some nonsense, and it asks me again. I put in something correct, I put in a float, so it does ask me again, and here we are. So now I have the values stored in my value list. Now this is useful. Next we have to ask ourselves whether we have a real solution, and we do this by looking at the discriminant. So first we need the numpy package for the square root. So I do an import statement numpy snp. And then I checked the discriminant. Now we store our parameters values in the value list. So val1 using indexing refers to parameter value b. That's the second position. Again, note Python starts counting from 0. So here we have the value b to the power of 2 minus 4 times a times c, again using indexing. So that's the discriminant. If the discriminant is equal to 0, we have a special case which I cover in the elif statement, and I would then print my factorization accordingly. Otherwise, I would display there is no real solution. Good, so that should do it. Let's run it one more time and see what happens. So let me correctly specify a number. I do another number here and one here. And I have now a factorization which looks quite complicated. The only thing which I haven't fixed is the minus minus, which should be then a plus, but you know that's acceptable, but otherwise the code works. So we can do a simpler example, the one we used before, and then a minus 2. and we should get our factorization as x minus minus, which is plus 2, and x minus 1. So that's all for this session. It's a quick introduction into how to use Python for looking at mathematical problems, and I see you in the next one.